Now we will take some quadratic equations and we'll solve them by formula. So here in this first question, I've deliberately taken a question where the factorization is possible. As you can see, 6 into 4 is 24, and plus by adding them we should get 11, so it is 3 into 8, right? So here factorization is possible, but we'll still go ahead and apply the formula here just to see whether the formula is applicable or not. This is the formula that I've written here. For a general quadratic equation, ax square plus bx plus c equal to 0. This is the formula to find the value of x, where a is the coefficient of x square, b is the coefficient of x, and c is the constant term with their proper sign. Right? So even if in this question, even if the factorization is applicable, we'll go ahead and apply the formula to just see how it is useful here. Okay, now in this case, we can see that a is equal to 6, b is equal to minus 11, c is equal to 4. So the value of x in this case will be equal to minus b, that is minus 11, plus minus square root of b square, that is minus 11 square, minus 4ac. So 4 into a is 6, c is 4, divide by 2 into a is 6. Alright, so what we have here is minus of minus 11 is 11, plus minus square root of minus 11 square is plus 121, minus 4 into 6 is 24, 24 into 4 is 96, divide by 2 into 6 is 12. So this gives us 11 plus minus. Now 121 minus 96 is 25. 25 square root is 5, divide by 12. Now if I take plus sign, it will be 11 plus 5 by 12. Alright. If I take minus sign, it will be 11 minus 5 divided by 12. So what we get from here is 11 plus 5, 16 by 12, or 11 minus 5, 6 by 12, right? So this gives us 16 by 12 will be 4 times, 4 3 times, and 6 by 12 will be 1 by 2. So the answer is either 4 by 3 or 1 by 2. Now please understand that here, even though we have applied the formula, we could have done the factorization also because the roots are rational. And remember, factorization is possible whenever the roots are rational. Now the idea is this formula is universal. This formula should be applicable in all cases, in all possible situations. So whether it is factorizable or not, the formula is universally applicable, right? So the first question, the answer is 4 by 3 or 1 by 2. All right. Now let's go to the next question. Now the second question, it says 3x square minus 17x plus 10 equal to 0. Even in this, the factorization is possible, but we'll go ahead and apply the formula here. Here we have a is equal to 3, b is equal to minus 17, and c is equal to plus 10. Right? This is the formula that we have to apply. So the value of x will be minus b, so minus of minus 17, plus minus square root of b square. So it is minus 17 square minus 4ac. So 4 into a is 3, c is 10, divide by 2a, so 2 into 3, right? So what we have here is x equal to minus of minus 17 is plus 17, plus minus square root of minus 17 square is 289, minus 4 into 3 is 12, 12 into 10 is 120, divide by 2 into 3 is 6. So what we have here is x equal to 17 plus minus 289 minus 120 is 169, and square root of 169 is 13. Divide by 6. So by taking plus sign, we will have 17 plus 13 divided by 6. Or by taking minus sign, we'll have 17 minus 13 divided by 6. So the final answer will be 17 plus 13 is 30 divided by 6. Or 17 minus 13 is 4 divided by 6. Now 6 cancels 30 5 times. 2 cancels 4 2 times, and 6 3 times. So the answers are either 5 or 2 by 3. So the answer of the second question, the roots are 5 or 2 by 3. Again, the roots are rational. That means the factorization must have been possible, and the formula also should be possible. Here we have solved by using the formula. Let's take a couple of more examples. So now we'll take the examples in which factorization is not possible. Let's take a look at them. Now let's take up the third question. We'll straight away apply the formula. Let's identify the values here. The value of a, the coefficient of x square, is 1. The value of b, coefficient of x, is minus 6. And the value of c, constant term, is minus 11. So the value of x will be equal to, according to the formula, it is minus of b. So minus of minus 6 plus minus square root of b square. Now b square is minus 6 square. Alright. Minus 4 into a is 1, c is minus 11. Divide by 2a, so it is 2 into 1. So x is equal to minus of minus 6 is plus 6, plus minus square root of, now minus 6 square is 36, minus 4 into 1 into minus 11, that is plus 44. Alright, divide by 1 into 2 is 2. So this gives us, it is 6 plus minus 36 plus 44 is equal to 80. So it is square root of 80 divided by 2. So it is x is equal to 6 plus minus. Now see, 80 is equal to 16 into 5. So square root of 80 will be square root of 16 into 5, that is 4 root 5. Alright, so it is 6 plus minus 4 root 5 divided by 2. So if you divide by 2, you get 3 plus minus 2 root 5. So the roots are either 3 plus 2 root 5 or 3 minus 2 root 5. Now, as you can see, in this case, the factorization was not possible because the roots are not rational. Also, if the roots are irrational, they have to be conjugate, and they are. Right? So, irrational conjugate roots. So, in any case, the answers in this question are 3 plus 2 root 5 and 3 minus 2 root 5. Okay, a pair of conjugate irrational numbers. Alright, now let's go to the next question. Now the fourth question, clearly a is equal to 1, b is equal to minus 12 and c is equal to 8. Alright, so straight away apply the formula. X is equal to minus b, so minus of minus 12, square root of, plus minus square root of b square minus 12 square minus 4 into ac, 1 into 8, divide by 2 into a, that is 1. So we have x is equal to minus of minus 12 is plus 12 plus minus root of 12 square is 144 minus 4 8 is 32 divided by 2. So this gives us 12 plus minus 144 minus 32 will be 112. So it is root of 112 divided by 2. Now 112 is actually equal to 16 into 7. So root of 112 will be root of 16 into 7. Alright, now root of 16 is 4. So this gives us 4 root 7. Okay, so it is x equal to 12 plus minus 4 root 7 divided by 2. So we have 6 plus minus 2 root 7. Right, so as you can see, again it is 6 plus 2 root 7 and 6 minus 2 root 7. Conjugate roots because they are irrational numbers. So irrational roots will always be conjugate. Alright, now let's go to the next one. Now in this fifth question, as you can see, a is equal to 1, b is equal to minus 10, c is equal to 74, right? So we can directly apply the value of x will be equal to minus of b, that is minus 10, plus minus square root of b square, that is minus 10 square, minus 4ac, so a is 1, c is 74, divided by 2a, that is 2 into 1. So x is equal to minus of minus 10 is plus 10, plus minus square root of minus 10 square is 100, minus 4 into 74 is equal to 296. Divide by 2. Now this is equal to 10 plus minus 100 minus 296 is minus 196. So it is square root of minus 196. Oh, that means this is square root of negative number. So it has to be an imaginary number, right? So what we can do is we can take it as root of minus 196. We can take it as square root of 196 into minus 1. Okay, now 196 square of 14, so it is 14 outside, 14 root of minus 1, and root of minus 1 is given as I, so it is 14i, right? So that means x is equal to 10 plus minus 14i divided by 2. So if you divide by 2, it will be 5 plus minus 7i. So as you can see very clearly that it is 5 plus 7i and 5 minus 7i, right? Now these are imaginary numbers and they are also in pairs. So if you remember, even the imaginary roots were also conjugate. So imaginary conjugate roots, right? So the idea to show all these examples to you is that this formula is applicable in all cases, whether it is possible by factorization, whether the roots are irrational or imaginary or anything. All right, let's take one more question. Now in this one, a is equal to 4, b is equal to minus 4 and c is equal to 37, right? So straight away apply the formula. X is equal to minus b, so minus of minus 4 plus minus root of b square, that is minus 4 square minus 4ac, so it is 4 into a is also 4 and c is 37, divide by 2a, so a is 4, 2 into 4. Right, so x is equal to minus of minus 4 is plus 4 plus minus root of minus 4 square is 16 minus 4 into 4 is 16 into 37. Alright, now 16 into 37 will be 592. divide by 2 into 4 is 8. So this gives us 4 plus minus square root of minus 16 minus 592 will be equal to minus 576. Fantastic. Now 576 is 24 square. So once again, minus 576 can be taken as square root of 576 into minus 1. Square root of 576 is 24. Then root of minus 1 is taken as I. So it is 24i. So we say that here it is divided by 8. So we say that x is equal to 4 plus minus 24i divided by 8. Right? So it is, if we divide by 8, 4 by 8 will be 1 by 2 plus minus 24 by 8 is 3i. Fantastic. So the roots are 1 by 2 plus 3i or 1 by 2 minus 3i. Very clearly, again the roots are imaginary and hence they are conjugate pairs. Alright. So I think this is sufficient practice for quadratic equation solving with the help of formulae. Okay.